everyone, and welcome to Groundwater Talk Live. I am Tom Beller, the Groundwater Guy, your host for today. And today we're going to be doing part one of a three-part series. We're going to talk about technical, managerial, and financial requirements for water utilities. Now, this is an operational parameters for water utilities, and so we're going to get into that. And because it's a fairly complex topic, we're going to break this into three parts, and today we're going to be discussing the technical aspects. So, but before we get going on that, let me ask you to like, comment, and share if you appreciate these videos or you find them useful. Then like and share. If you have any comments or questions, please feel free to post that to the video, or I'll give you my email address towards the end of the show. You can email me. I'm always happy to hear from people, and I pretty much always respond to the comments. So unless I miss them or something, but I always respond to comments, and I always look and respond to comments, and it really helps us get the word out and helps us move up through YouTube's algorithm that really looks at these things. So if people are watching the videos, if they're liking them, they're commenting on them, they're sharing them, then I get better rankings and more people see it, and we can get more subscribers and just kind of get more exposure. So I appreciate everybody that has commented in the past, and keep it up. Thank you very much. All right, so today what we're going to be talking about here is the technical, managerial, and financial guidelines. Now, the TMF guidelines provide a comprehensive framework for water utilities to operate efficiently, manage their resources effectively, and ensure they can provide a consistent supply of safe and affordable drinking water for their customers. So that's really the bottom line on that. It's best management practices is really what it comes down to. However, there are certain circumstances where these things are required, and especially if you're going to get loans through the State Revolving Fund. California puts out a comprehensive set of instructions for meeting their specific TMF requirements, and so those are available online. This is just the front page I'm showing you here. So where are these required, and where do they just become best management practices? And we really want utilities to employ best management practices. So these are things that they should always be doing, but you're going to need to show you meet these if you run into certain circumstances. So the TMF elements are broken down into 13 areas, and so you can see that there's three areas where they're going to be required. If you want to go for State Revolving Fund, loans, grants, and anything through the state, in California anyway, they're going to require the TMF requirements. A new water system is going to require the TMF, you meet with TMF requirements, and change of ownership. Now, there's going to be a comprehensive form that is available online that you're going to have to go through and fill out. We're not going to go through that particular form because it's going to vary state by state. There's an EPA guide too that you can look up. We're going to hit the highlights here and get into a little bit of the details on what's required in each of these areas. But you can see there's 13 areas here. They break down. We're breaking it down a little bit differently, but this is California's version of this. So if you go for the State Revolving Fund, for instance, you're going to have two categories. You're going to have mandatory, and the mandatory are TMF requirements that you're going to have met before you submit the application for funding. Necessary means that you're going to have to do it, but you're basically, after you submit the application, you basically have 6 months is usually what it comes down to. It's going to be a negotiated time period, but you usually have about around 6 months to meet that requirement as part of your application. So you can see new water system, most of these are mandatory. Policies are necessary, and policies kind of evolve from your water system, so you're going to have a few board meetings to get those down. And change of ownership, there's some mandatories and some necessaries. Um, Obviously, training is going to happen afterwards. Also, so that's going to be getting things going. But probably the most important one for most people, because most you're not starting a new water system too often. Change of ownership, you may have some consolidation, but you're consolidating existing districts, so a lot of these requirements are being met. So really where this impacts most people, where you're going to need to meet these things, is if you go for State Revolving Fund funding for your water district. Okay, so that's that. So the TMF overview, and we shorten that technical, managerial, financial, we shorten it up to TMF because otherwise it's a mouthful. So what they do is they address a 40,000 foot overview, I guess, is they address the utilities infrastructure, regulatory compliance, water quality, and the adoption of technology and innovation. So these are different areas. We're going to break it down into these areas and discuss that. The technical requirements. Next week we'll do managerial, and the week after that we'll do financial requirements, because there's a lot to bite off in each of these, and you don't want to watch 2 hours of the show just to get through all that. So, all right. So the managerial requirements focus on effective leadership, governance, human resource management, customer service, and asset management. A lot of the boring stuff, but stuff you really need to run efficiently. And then financial requirements, they deal with revenue stability, budgeting, financial planning, rate setting, financial reporting, access to capital. So your capital improvement plan would be there, your rate setting would be there, and just making sure you have enough money to operate things day to day. So that is the overview. Like I say, today we are going to address technical requirements, and then we'll get into these other ones in subsequent weeks. All right, so the guidelines provide a comprehensive framework for water utilities to operate efficiently, manage their resources effectively, and ensure they can provide a consistent supply of safe and affordable drinking water to their customers, like I mentioned earlier. Now, that said, these are really best practices that most water districts should be employing anyway. But like I say, if you're going for funding, then you're going to need to absolutely make sure you meet these requirements in accordance with whatever state you're in, or the EPA requirements if you're in a state where the EPA is the lead agency. So most states manage their own. So in California, for instance, that I reference a lot, the state manages that. So they got their own guidelines and break it down a little bit differently than I may present it here. I'm presenting more of a detailed, generalized approach. But so you get the idea. I mean, we go into training and we dive into a lot more details with examples and stuff, but that's more than we can cover in a show here. So with the whistle here. All right, so moving on. Technical requirements ensure that utilities maintain reliable infrastructure, comply with regulations, and consistently provide high quality water to their customers. So that's basically a summary of the technical requirements. We'll dive into the different details here, but that's really what we're looking at. And so it's the technical aspect, and that's really where I deal a lot with the water wells and stuff. That's all going to source water. That's generally going to fall under technical requirements. Everything that it takes to operate the distribution lines, that's all going to be in your technical requirements. So breaking it down into the various components, infrastructure management is number one under the technical requirements, and then we'll get into detail on each of these. I'm providing an overview of the different areas, and then we'll get into details on each of these. So that includes water sources, treatment, distribution systems, storage facilities, infrastructure maintenance, and rehabilitation. Pretty much everything you think about when it comes to actually operating the water system and getting water out of the ground or from your surface water source treating it and getting it out to the customers. That is what infrastructure management encompasses. So it's an essential component. Obviously, if you can't get water to the customers, then why do you exist? So that's number one. And there are the technical requirements. Regulatory compliance. The state in most cases and the EPA oversee compliance with the regulatory standards. So water utilities must adhere to state and federal requirements. And the Safe Drinking Water Act and the Clean Water Act are the main ones. Different states have different requirements, and most states administer these for the EPA. So they're establishing the standards for water quality, monitoring, and reporting. And the reporting is a huge component of this. We'll do a subsequent show on consumer confidence reports where water districts report back to the public what's in the water. Yeah, but that would be part of this too. Your regulatory compliance is maintaining adherence to the applicable regulations and making sure your water is safe and meets the standards for drinkability to protect the public health. And so, all right, water quality and monitoring. This kind of overlaps with the previous one, but utilities must monitor and report on various contaminants and maintain water quality standards set by the EPA and state. So you also have to have emergency response plans for any contaminant events. So if for instance you have arsenic in your well, and arsenic is a very common contaminant out there. So if you have arsenic in your well, but you're under the MCL, the regulatory standard for drinking water, but you're kind of getting close or it's creeping up a little bit, your monitoring is going to be very important, and you're going to need to have a contingency plan in place in case you start exceeding the MCL for arsenic in that case. Nitrates, same types of things. There's a lot of different contaminants we deal with regularly. So the water quality and the monitoring is an important component. Most states are going to have they're going to have a whole host of things you're going to have to monitor for. You're going to have to monitor for it on a regular schedule, and the schedule is going to generally be, for instance, in the state of California, it's going to be dependent on how big your water system is. Obviously, a bigger water system, more water sources, you're going to have to monitor more frequently than a small system with maybe 2 wells, and so that's really what it comes down to. But there's mandatory things you're going to need to monitor for, and then have an emergency response plan in place in case you start exceeding those things. You got to start looking at things and do whatever you need to do depending on your particular circumstances. An emergency response plan is going to be very particular to your particular water utility. All right, and lastly, the last general category in the technical requirements is technology and innovation. This is going to include stuff like water loss control, leak detection, and energy efficiency. So leak detection is a huge deal because a lot of water systems, you got your distribution lines underground, valves leak, pipes corrode and start leaking, and you start losing a lot of water. And most water districts will track their water losses and try to manage them to a certain extent. Sometimes they're just unexplained, but there's a lot of technology out there that's available for tracking down leak detection, sonic methods, and just listening methods underground. It's pretty amazing. I know a number of leak detection specialists that just specialize in leak detection, and it's a big deal. And really, a water district can save a lot of money by just controlling their leaks. And leaks happen. It's just part of the business. Things get old, things break, and you develop leaks. The trick is to track those leaks down and to stop them, make the necessary repairs, because water leaking out somewhere is water that's not going to the customers, water you can't charge for, and it's stuff you're paying for to get out of the ground or from your surface water source, but you're not getting any benefit from delivering to the customers. So leak detection is really a huge deal. And if you're experienced, you should be looking at, as a water utility, you should be looking at leak detection on a regular basis and understanding what your water losses are and develop a plan to deal with that. So, and then smart water systems and data management can further help in that area, because you're going to be automated, and a lot of systems have automated systems that can allow them to determine what their water losses are automatically, and just push a button and out pops a report. You know what your water losses are. If your water losses went up this month, then that's something that you need to start looking at. And lastly, unfortunately, there are people out there that steal water. You get illegal taps, and this is really true. I looked at some down in the Mojave Desert in California, which seems to be a popular place these days for growing marijuana. And they will sometimes tap into water systems illegally, steal the water, and you never know until you get a water loss. If you're not monitoring your water loss, you may wonder where all your water is going and not have an understanding of what's going on. So, but beyond just the cannabis operations, there are people that just do the illegal taps. So understand that's all lost revenue, and revenue that's not going back to support the district and support the financial part of your TMF requirements. All right, so now the details. That's the overview. We did the TMF requirements, so like the 40,000 foot view. Then we went to like the 25,000 foot view. Now we're down at we're going to get into the the ground level or the 5 or 10,000 foot view. So, all right. So first one, infrastructure management, water sources and treatment. So obviously. Oh, there we go. I think we got it back. Thanks, Jason. So we got it back. I must have hit the wrong button. So all right, let me go back and so water utilities must ensure they have reliable water sources and effective treatment processes. So your water source is key. Most water districts are going to need to have both a backup water source and a primary water source. So yeah, thanks for letting me know on that, Jason. So most water systems need to have the backup source, but you need to maintain that backup source, and that it needs to be ready if you need it. So most bigger water systems are going to have multiple water sources. Less of a problem, although the demands on those water systems may be such that if you lose some of your sources, you could not have enough water, and so that becomes a situation as well. A lot of water systems will also have emergency interties with neighboring water systems. That's all part of assuring you have reliable water sources. So, so anyway. The water sources and treatment involves identifying, protecting water sources, implementing appropriate treatment technologies. If you have iron and manganese, for instance, you're going to need to treat those. There are secondary standards for that. And then you're going to need to maintain your treatment facilities and with the goal of meeting the water quality standards. All right, distribution systems. Distribution systems are crucial for delivering the water. You got your source water now. We've addressed that previously. Now we're talking about distribution systems, and that's getting the water out to the customers. That's going to be the pipelines. That's going to be the valves. That's going to be the tanks that store the water, and whatever else you have that's going to deliver the water to the customers, the meters, all that. So utilities, this is really where a lot of the maintenance goes into, is maintaining the distribution system. So you need to have plans in place, and part of the financial requirements are to make sure you have the financial capacity to do upgrades and maintain your systems. But that's also part of the technical component, is you really need to have a plan in place that you're going to inspect these systems, you're going to replace them as needed, and keep them operational. Because everybody knows that nothing breaks during regular working hours. It's always 3 a.m., usually on a holiday, when things break, and you got to call people and get them out of bed and get them out there. That's when it happens. You can just count on that. I've never talked to anybody that hasn't had that happen to them. And they say, yeah, why is that? You'd think that the law of averages would say that things would break during regular working hours sometimes, but no, it's always in the middle of the night, usually on a holiday. So by maintaining your system regularly, you're going to minimize those middle of the night call outs and then upgrade as necessary. And part of the whole asset management plan that we've talked about in other shows is really having a replacement schedule for all your equipment. Everything has a class life attached to it. You have a useful life that's left, and then you really look at needing to replace that and having the financial wherewithal to do that on the proper schedule, and that's going to minimize your problem. Emergencies will still happen, things will still break, but you're going to minimize the amount of middle of the night call outs. So that's really important. All right, storage facilities. I usually think of that as part of the distribution, but we're looking at storage facilities a little bit differently, because what you're doing, most places are going to pump. The water demand is not going to be the same throughout the day and the evening and through the night. So we're pumping, we're filling up these storage facilities, and that's going to provide a little bit of a backstop to us in case we have a pump where we need to do some maintenance. We're going to have that storage facility, but it's also going to be part of our management plan. You may have a storage facility, you may be up in the mountains where you have pressure zones, and those storage facilities are actually going to be part of that process where you pump the water up to them, and then it's going to gravity feed out to the customers. And I've seen in the mountains where they're pumping it up to the top of the mountain, and they got some pretty good water pressure from the drop. But you can get pretty good water pressure without a lot of elevation change. So that's important. So the storage tanks are going to require maintenance like everything else. Steel tanks tend to rust and corrode. We put coatings on them; those need to be maintained. So that's what you're going to need to do. So. So there you go. Proper design, construction, maintenance of these facilities helps the utilities maintain adequate water pressure, ensure water quality, and meet peak demand. So that's water. Maximum daily demand, peak hourly demand are calculations water districts should all know by heart, and you need to manage your system with storage and with the distribution and your water source to be able to meet those. That's one of the minimum standards you need to meet, is maximum daily demand, but especially peak hourly demand, because that's going to be the maximum stress on your system, and you need to have your system designed to deal with the peak hourly demand. All right, maintenance and rehabilitation. This is kind of a catch-all component. You gotta do the repairs. You gotta do the upgrades. You have to rehab things as needed. And rehab, I'm talking about the pipelines as well as the wells. I do a lot with well rehabilitation. That is certainly part of this. But you don't, I'll get back to my statement earlier. You don't want to have these 3 a.m. call outs unless it's a true emergency. If it was something that should have been fixed and shouldn't, well, that's on you then. You got nobody to blame but yourself. You really need to do a regular maintenance plan. And this, a lot of this comes down to the planning you do. So that's the preventive maintenance program. Prioritize infrastructure investments based on asset condition assessments and risk analyses. That is your asset management plan. That's a little separate here from this. There's overlap, but the asset management plan is really where we go in and look at all our assets, valves, wells, whatever it is, components of our water system. And yes, planning is key. Components of our water system, and make sure that we're maintaining those. The asset management plan is a big part of that because you're looking at a regular replacement. You understand what's in your system, where it is. You've got it all located with GIS, and you can go out and you can dig up that valve if needed and replace it on schedule. So that's part of that is maintenance and rehabilitation. Probably most water districts, a lot of the people employed there are working on this component. They're out there tweaking things and making sure everything is operating properly. So maintenance and rehabilitation is a big part of where your personnel costs go. All right, next one, regulatory compliance. We'll look at the components of that. So the primary laws that are out there are the Safe Drinking Water Act and the Clean Water Act. Those are the primary federal regulations. Safe Drinking Water Act sets standards for drinking water quality and monitoring. The Clean Water Act focuses on protecting surface water quality. Usually most states is going to have their own environmental protection. In California, for instance, it's the state region or the State Water Resources Control Board monitors this through their regional water quality control boards. In Tennessee, where I live, for instance, it's the TDEC, the Department of Environment and Conservation. They got a drinking water program under that. They're going to monitor that at the state level. They're approved by the EPA to assure compliance with the SDWA and the CWA. So that's a component you want to comply with these, and that's where everything is going to flow from. You need to be in compliance with these, and that's where all the monitoring comes in. Is you're going to have to monitor to make sure you're in compliance and you're delivering safe water to your customers. Boy, you don't want to be fielding those complaints that you have bad tasting water or you've the worst thing in the world is to have to send out boil water notices to your customers. Boy, people get upset with that. I will tell you that. I have heard from a number of water districts, and boy, that is the worst thing. They've been directed to issue a boil water notice because they had a coliform violation, and people get pretty ticked off. So you want to make sure that you're doing the monitoring and staying in compliance with these things. That's the whole idea there. Other relevant regulations, there are other federal and state regulations, wastewater discharge, stormwater management, infrastructure construction permits, different operating permits. These are all things that you need to stay in compliance with. The Safe Drinking Water Act and the Clean Water Act are obviously the big ones, but there's a lot of little components that you need to comply with as well. And it can be a headache to comply with all these things, but it is important that you not only comply with those, but you stay abreast of what's happening. This is where joining a state organization like in Tennessee, the Tennessee Association of Utility Districts, in California, the California Rural Water Association. These associations will really help you stay abreast of the regulatory compliance issues, any new laws, changes to the laws that can impact you, and other compliance issues. So it's really worthwhile to join these organizations just for the fact that they will keep you abreast of things, and you don't have to spend a lot of time tracking down this information on your own. You can if you want, but I find it much easier if you join the state organization and communicate with them, because their job is to keep track of this stuff and notify their members of that. So that's why they exist, and I think it's well worthwhile joining those organizations to stay abreast of these things. All right, water quality and monitoring. So number one here is contaminant monitoring and reporting. Water utilities must regularly monitor contaminants in their water supply, and they need to report the results. So the monitoring schedule is going to vary in most states by the size of the water districts, how many water sources you have, and those types of things. But the components you're going to need to measure are going to be those things under the Safe Drinking Water Act that are going to have MCLs attached to them. Some things that don't have MCLs attached to them. Some things that have secondary MCLs, like iron and manganese, don't have primary MCLs. They have secondary MCLs that are still enforceable in some states. Like California enforces secondary MCLs, just like they would a primary MCL. So it's really no difference between secondary and primary MCLs in California. Other states do it a little differently. But there are components that we're required to monitor for, especially if you have contaminants, but other components we're required to monitor for that may not have MCLs, but it's a matter of tracking. And sometimes this is going to be if we have a constituent that is an emerging contaminant, for instance. They may be gathering information, so they may require monitoring to see how prevalent this contaminant is, and to develop regulatory standards and MCLs for that component. So sometimes that monitoring will be in place, but you'll usually have a schedule that you need to adhere to. Like coliform samples have to be daily, but other things are going to be quarterly, monthly. There's going to be annual. So and some are, like in a lot of small districts. Uranium monitoring radionuclides is going to be longer than a year, depending on whether you've had any violations or not. So you're going to need to demonstrate compliance, and also the reporting is those consumer confidence plans that go out to the customers. You see those in your bill. They come once a year, and most people just ignore them and they throw them away and don't look at them. But you really should look at them, because it tells you what problems your water district has. And for instance, if they have consistent problems with things, they're probably going to need to deal with it, and you may end up seeing a rate increase. So as a customer, you probably want to pay attention to what's in your drinking water, and maybe what's coming down the pike. All right, maintaining optimal water quality standards. So a little bit more nebulous on this one than the monitoring and reporting, but we want to maintain optimal water quality standards to ensure the consistent delivery of safe drinking water. We don't want to always be going offline. Controlling taste and odor is kind of a nebulous issue. Disinfection byproducts, if you're using surface water and you're chlorinating, you are probably going to get disinfection byproducts, so you need to manage those. And so that's going to be different constituents that fall into a couple different areas. Trihalomethanes is one, haloacetic acids is another, and those are formed from the combination of organics, and the chlorine will form disinfection byproducts. More common in surface water, because you're getting more organic carbon in your surface water, as opposed to water wells does not have a high organic carbon component, so you'll see less in the way of disinfection byproducts in groundwater, for instance. And you want to prevent the growth of harmful microorganisms. Now, I deal a lot with microbiology in wells as part of my job. We don't monitor enough microbiology in wells. We monitor for total coliform fecal and E. coli. We don't monitor for total bacteria loads, for instance, and that can affect taste and odor. and can cause potential health issues, and we're not necessarily monitoring for some of those things. So I really, when I work with water districts, I urge them actually to be looking at much more than beyond just the required coliform monitoring. You want to look at total bacteria count, because so many things go on in your well that have to do with bacteria, iron deposits, manganese deposits, corrosion, as well as taste and odor issues. There's a lot of problems in wells that can relate directly to bacteria in the wells. So and just stuff that we're not required to monitor that we should. So that can give you a heads up on potential problems you might have. So that goes back to providing a reliable and high quality water supply to your customers, is really understanding what's going on beyond just the required monitoring and reporting. So emergency response plans, we addressed that a little bit earlier, but utilities are required to have emergency response plans in place to address potential contamination events. So this can be something where it's natural in the groundwater. Arsenic is almost always going to be naturally in the groundwater, but sometimes it can increase. Nitrates are man-made. They're going to be surface water. You see rising nitrates. Now you're going to have some kind of plan in place. You start to exceed the nitrate MCL. How are you going to deal with that? If there's a release near your well, a tanker truck turns over and starts dumping petroleum hydrocarbons in the ground near your well where it can get in the well, you need to have an emergency response plan to deal with that. So emergency response plans a lot of times are best guesses at what could happen and then how we're going to respond to that situation. And then you need to have some generic categories in there, because you're not going to get it always right. Something's always going to happen that you didn't anticipate. So you need to have some general components to your emergency response plan. So that's going to outline the roles of the utility staff, any communication protocols, and that's going to be really important to get back out to your stakeholders. We've had an incident. We want you to know right away. You need to notify them, because if they read about it in the newspaper and you haven't notified them, you're going to be hearing about it. So you really need to communicate that as quickly as possible. And that's just good management. I know people don't like to spread the bad news, but you need to do that. You need to get the word out right away as soon as you know there's a problem. So and then you need to just have the procedures in place. Like I say, sometimes this is best management practices on these things, and you may not cover everything, but you should have enough there that which you can address any unknowns as well. So if you got a good emergency response plan in place, you can minimize the impacts. You'll know how to respond quickly and get it taken care of as soon as possible, and minimize the impacts to your water system. All right, so getting into the last category, details. Technology and innovation, water loss control, and leak detection. As I indicated earlier, huge component here. Most water systems are going to have water loss and leaks, whether it's through degradation of equipment, holes in pipes, leaky valves, or people stealing the water. It happens, and sometimes it's hard to track this down. I've been involved in some of these studies where they've looked at an entire small water system, and it ends up being a real mystery sometimes. Where the heck is the water going? But you need to track it down, because lost water is lost revenue, and a lot of times small water districts don't have the financial wherewithal to really lose a lot of money that way. You want to get every dollar back into the system, and you should. You produce the water, you've spent the money to produce it on behalf of the ratepayers, and so you should be maximizing the revenue based according to your rate schedule for the water that you send out. So it shouldn't be disappearing into the ground. It shouldn't be being stolen by somebody. You should be getting paid for every drop that goes out there according to your rate schedule. So water loss is a huge deal for most water districts are dealing with this. So there are a lot of technologies out there. One company that we deal with is American Leak Detection. They're nationwide. They that's what they specialize. A whole company that just specializes in helping you identify water loss and leaks. So that's a huge deal. It's any investment you make in water loss control and leak detection is money well spent, as far as I'm concerned. All right, energy efficiency. This kind of gets into the weeds a little bit. I'm all for energy efficient. We're coming out with new pumps, for instance, that are more energy efficient, and so that's something we want to look at. We're using variable frequency drives to improve the efficiency, so you're not just running flat out. You can control how much electricity is going down there, and just even I'm a water well guy, so just even the efficiency on the well can make a difference. A well that's plugged up is you're gonna be working that pump harder. You're gonna be using more electricity. As a matter of fact, one of the things we look at for when you need to rehab a well is the gallons per or the dollars per, what is it? Gallons per kilowatt hour measurement that we do. So you can actually track that over time and see the loss of efficiency as your well plugs up, because you're pumping more, you're using more electricity, but you're either producing the same or less water. And so that means something's going on in your well that makes it less efficient. So just cleaning the well, even if it's not a pump issue, just cleaning the well is going to make that pump operate more efficiently, and you're going to save money. So that's a component there. That's a situation I'm very familiar with, but there's other ways you can get energy efficiencies. I don't know how applicable renewable energy is. I've seen some people using it for certain components of water systems. I've seen some remote wells that are powered with solar. Obviously, you got to have a battery set up and all that on that, or they don't run at night when there's no solar power. So, but that's I put this in there for the sake of completeness. So, yes. There is a solar solution. Solar is going to be more efficient when it does work. It's not applicable to all situations, but obviously you're producing the sun, and solar power motors or pump motors that are geared towards use solar tend to be more efficient by nature, because you're going to not have as much power as you do, just connecting to the grid. And so they're going to be more efficient by nature, and you're not paying for the electricity. After your initial investment, after you've capitalized that initial investment, then it's going to be much more efficient. But it does not always work if you're pumping 2,000 gallons a minute with a big turbine pump. You may need a lot of solar to power that. I'm looking at smaller wells where solar may be a viable solution. I've worked on a few of those, and it can work for smaller wells. It gets a little more dubious to run your own solar powered pump for a bigger water system and bigger wells. So it can be more efficient for smaller districts. Is basically how I'll leave that. All right, and then kind of the last component here is smart water systems and data management. This is really taking advantage of the technology. So this can go back to the efficiency as well. As if you have smart water systems, smart meters, and data management, you can more effectively operate your system and optimize your performance, and that's going to lead to energy efficiencies as well as just overall management. So most districts now are employing things like SCADA systems, and I'm drawing a blank on what SCADA system actually stands for, but SCADA is a technology that basically integrates remote sensors, and you get one readout on a panel, what your water level, what your static water levels are, what your pumping water levels are, how this valve is performing, how your treatment system is performing, how your chlorination system is performing. You can make adjustments right there at the panel. A lot of these things will have remote call-ins, so you can monitor your system 24/7 through these SCADA systems. And we've actually used these for pumping tests, and they're producing all the data we need, because we got transducers down the well that are measuring the water levels. So we don't have to employ any of that. We're just running off SCADA system data when we're doing a pumping test, and so it's great. So this really, I mean, a lot of times when you're running these systems, and I hesitate to say this, but you really can't have too much data, because data is really important, and it allows you to, if you sort through the data and use it in a meaningful way, then it can really help you manage your system more efficiently and more optimally. I see so many people that take their data, they write it down, or they get their lab data and they check it over real quick and throw it in a file, never to look at it again. You paid money to produce that data, make it work for you, and it can, because if you use it efficiently, there we go. Supervisory control and data acquisition, SCADA. Thank you. that was, I was just totally drawing a blank on that, even though we deal with SCADA systems all the time. So anyway, kind of winding that down. Using your data effectively goes a long ways towards optimal management of your water system is really what we all want. And even really small water districts can manage their systems effectively if they manage their data, if they produce the data, and use it effectively. So that's what I'll say there. Smart systems can really help you there. They're coming out with new stuff all the time. It's hard to keep up sometimes. I go to a lot of these water shows and stuff, and I'm always amazed at the technology that's out there. So, all right. So that is the show for today. Next week, we'll cover managerial requirements. That was quite enough. That was a lot of talking at you, but I appreciate you sticking around and listening. If you want to get a hold of me, you can contact me at tballard@groundwaterguy.com, or just leave a comment on the videos, and I'm happy to answer any comments. I always do. I go through and check those and answer those. So I appreciate that. If you want to be a guest on the show, then here is my Book Me page. You can come in and sign up for a show if you got the subject of interest to water users, water utilities, especially groundwater topics, because that's mainly what we talk about here, obviously. Come on the show. I'd love to have you, and then people don't have to listen to me all the time. They can listen to somebody else talk at them. So. We stream on the Groundwater Guy on a channel on YouTube, and all my past videos are there. We have like over 80 videos at this point. Also, we stream on LinkedIn, also Facebook and Twitch, although I really don't do well there. I just kind of stream because somebody told me I should, so I do that. But these are the main two channels. Anyway, thanks for watching. Don't forget to subscribe to the Groundwater Guy channel on YouTube. Punch the bell for notices. We do this every Thursday at 11 a.m. Central Time, and I'm always happy to see you here, and we'll keep producing the videos. Thank you very much.